today we're going to be talking about solving word problems that involve similar triangles. So I need to make sure that everybody has this piece of paper on their desk along with at least one highlighter. So if you do not have this on your desk, make sure you pause this video to make sure we're all on the same page ready to go. So I'm going to go ahead and I'm going to highlight my title. Word problems. Whenever you see word problems in math, you usually shut down. You usually think they are the hardest problems because they involve words. I'm going to be extremely honest with you. Word problems are actually the easiest problems, like on a test or homework or anything. They are the easiest problems to set up and solve, mainly because you have to read the context of the problem. So I don't want you to be discouraged when it comes to solving word problems. They are not hard. The hardest part is being able to draw the picture to figure out how we want to solve it. So to help us out, we have 6 steps. Step 1. Step 1, I'm going to obviously read the problem and draw a picture. I'm going to read the problem and draw a picture. That's my first step. My second step is I am going to set up an equation. And that is the hardest step. If you can set up the equation, it's easy. You're golden. Step 3, I'm going to solve. I'm going to solve anyway. So because in this case I'm talking about similar triangles, I'm going to be setting up proportions, and the proportions I'm then going to solve by cross multiplying. So here I'm just going to say solve the equation. Step 4. Step 4, I'm going to make sure answer is logical. When you're solving word problems, you want to make sure that the answer that you get is a logical answer. If you were solving something and you wanted to find the height of a tree and you got x equals -4, that's not logical. You can't have a tree that's -4 units tall. So you always want to make sure it's logical. And then step 5, you're going to write a therefore sentence. Why I say write a therefore sentence is because that also helps you, it forces you to think about step 4. So if you write a therefore sentence and it doesn't make sense, you know it's probably not logical. And when I say therefore, yes, we can use the symbols for therefore, which looks like that. And there actually is no step 6, so you can go ahead and cross this out. So step 1, I'm going to read the problem and draw a picture. Step 2, I'm going to set up an equation. Step 3, I'm going to solve the equation. Step 4, I'm going to make sure my answer is logical. And how I'm going to make sure my answer is logical is I'm going to write a therefore sentence. Your therefore sentence, the way I always think it's just good habits that if you start with words, you end with words. So, this is not letting me move. Okay, cool. Let's check this out. Let's look at these examples. Now, the examples that have the pictures provided cause the problems to be even easier than the problems where you have to draw the pictures. It makes it a little bit harder. So let's look at this first example. It says a person is standing 40 feet away from a 30-foot light pole. If the person casts a 10-foot shadow, how tall is the person? All right, so let's try this and try to fill out our pictures best as we can. A person is standing 40 feet away from the 30-foot light pole. So where does 40 feet go? Well, 40 feet, this person is 40 feet away from this light pole, so 40 feet goes here. So 40 feet goes there. And it says it's the 30-foot light pole. So 30 feet light pole, so the light pole is 30 feet. And it says if the person casts a 10-foot shadow, this is going to sound really ridiculous, but a lot of people don't know where shadows go. Think about it. When you're walking on the street, and you have your shadow, where is your shadow? Is your shadow on the ground or is your shadow up in the air? Your shadow is always on the ground. Your shadow's never going to be this distance here because that's up in the air. Your shadow is always on the ground, so 10 feet goes right there. If you need to write that down so your brain remembers, shadow is always on the ground. It sounds super silly, but there are a lot of people who forget that. So now my question it's asking me, how tall is the person? So I have to label X on my picture, so I want to know how tall this person with that super long neck is. So okay, I'm now going to set up a proportion to solve for X. I have two similar triangles, little triangle over big triangle. So give me a value, one of my little sides, well that's X. X corresponds to 30, equals my other little side is 10. 10 corresponds to 40. So now I'm going to go ahead and I'm going to cross multiply. 30 times 10 is 300. 40 times X is 40X. I'm now going to divide by 40 to get X. Divide by 40, divide by 40. So X equals 7.5. So that's telling me that this person is 7.5 feet tall, which is extremely illogical, but based on the answers in the problem that it gave me, this is my answer. So therefore, the human giant is 7.5 feet. So if I'm talking about my logical answer, yeah, that's probably not logical. But the main thing I really am stressing when it comes to logical is that you're talking about making sure it's not saying someone is negative feet tall. That doesn't make any sense. So just kind of keeping that in mind. And maybe that's why the stick figure has such a long neck. So let's go ahead and look at the next one. If a tree casts a 24-foot shadow at the same time that a yardstick casts a 2-foot shadow, find the height of a tree. So it says the tree casts a 24-foot shadow. So where is the tree shadow? Well, the tree shadow is down here, so that's 24. And at the same time that the yardstick casts a 2-foot shadow. So here's my yardstick. So its shadow is here, that's 2. Find the height of the tree. So the height of the tree, that's X right there. The only problem is I don't know the length of my yardstick. Well, how many feet are in a yard? Well, there's 3 feet in a yard, so I can put 3 here. So, okay, now I'm going to go ahead and set up my proportion. Little side, 2, corresponds to 24. My other little side is 3, corresponds to X. I'm now going to cross multiply. 24 times 3 is 72. 2 times X is 2X. I'm now going to divide by 2. So X equals 36. So therefore, the tree is 36 feet tall. Now notice my therefore sentences are not essays. They might not even be a complete sentence because I'm using symbols and abbreviating. That's fine as long as it ends in words and you include your units. Otherwise, you'll lose points. So, let's try number 3. A bush is sighted on the other side of the canyon. Find the width of the canyon. So, the width, so here is these waves here. Here's your canyon. So it wants to know the width, which is this distance, which we'll label X. So I'm going to go ahead and set up my proportion. So if you need to highlight your little triangle so you can see it, that's cool. So give me a side on my little triangle. 7.5 over 7.5 relates to X. My other little side is 10. 10 relates to 100. So now I'm going to go ahead and cross multiply. So 10 times x is 10x. 7.5 times 100 is 750. I'm now going to divide by 10. So x is 75. So therefore, the width of the canyon is 75 feet. Hopefully you're all doing okay and you're all following along with me. When you're good, go ahead and flip your paper. So I want you to go ahead and pause this video, and I want you to try number 4 on your own. Once you finish number 4, I want you to go ahead and unpause this video and we'll go over it together. So this problem says, how wide is the lake? So notice my lake is this right here, and I have X nicely labeled. So I'm going to go ahead and highlight my little triangle because these stacking triangles are always the hardest. So I know X corresponds with 0.9, so I'm going to do 0.9 over X, little over big, equals my other little side, which is 3, over this whole side. A lot of you are going to tell me 1.5, but 1.5 is not a side of a triangle. I have to put 3 and 1.5 together to get this whole side. So 3 and 1.5 put together makes 4.5. So now I'm going to go ahead and cross multiply. So I have 3x equals, what's 0.9 times 3.5? Hold on, I don't know if I typed that in right. 0.9 times 4.5 is 4.05. I'm now going to divide by 3. So x is 1.35. So therefore, the lake is 1.35 miles wide. If you notice, the rest of these examples have no picture. So now I have to sit here and I have to figure out the picture. So let's go ahead and let's look at example 5. Example 5 says, a tower casts a shadow of 64 feet. A 6-foot tall pole near the tower casts a shadow that's 8 feet long. How tall is the tower? So, okay, I'm going to draw a tower, and yeah, you can turn into an artist if you want to draw a tower. Here's my tower. And I have a pole, so I'm going to also come over here and draw a pole. There's my pole. I know I should become a professional artist. So it says a tower casts a shadow of 64 feet. Shadows are always where? On the ground. So on the ground is here. That's 64. So now I have this pretty triangle. A 6-foot tall pole, so my pole is 6 feet tall, casts a shadow of 8 feet long. So where's my shadow? On the ground. That's 8 feet long. How tall is the tower? So I want to find that value x right there. So I'm going to go ahead and I'm going to set up my proportion. So what's my proportion going to say? 6 over x equals 8 over 64. Remember, it doesn't matter if you did 6 over x or x over 64. All that matters is that it's little over big and little over big, or the opposite. So now I'm going to go ahead and cross multiply. 8 times x is 8x. 6 times 64 is 384. I'm now going to go ahead and divide by 8. So x is 48. So my therefore sentence is going to say what? Therefore, the tower is 48 feet tall. So I want you to go ahead and pause this video, and I want you to try 6 and 7 on your own. When you finish 6 and 7, go ahead and unpause this video, and the answers will be on the screen for you. So if you notice, I put up example 6 as answer, x is 3, which means I then now have to just write my therefore sentence. So I can say, therefore, Brad's shadow is 3 feet long. I wanted to go ahead and actually go over example 7 with you, just to make sure that we're all on the same page. So it says triangle EFG and triangle QRS are similar. So I'm going to go ahead and I'm going to draw that. And I'm going to say EFG and triangle QRS are similar. The lengths of sides EFG are 144, 128, and 112. So it says the length of the smallest side of QRS is 280. So my question is how do I know where I want to put 280? So I have to come here. So since all my sides correspond to each other, since 280 is the smallest, I want to come over here and I go, okay, which one of these sides is the smallest on EFG? Well, 112 is the smallest, which means 280 is going to correspond to that. And so now it says, what is the length of the longest side? So if I come back over to EFG, what's my longest side? Well, 144 is my longest side, so I'm going to put an X on my longest side. So now I'm going to set up the proportion. X over 144 equals 280 over 112. So now I'm going to go ahead and cross multiply. I have 112x equals 144 times 280. I get 40,320. Divide by 112. X is 360. So I can say, therefore, the longest side of triangle QRS is 360. So hopefully everybody's okay with that. When you're good, go ahead and flip your paper. So now I want to go ahead and talk about right triangle similarity. So in order to talk about right triangle similarity, we have to review what the geometric mean is. So I'm going to highlight what is the geometric mean, and I'm also going to highlight where it says what is the altitude. So the geometric mean, remember we've learned the word mean before. The geometric mean is just the average of sets of numbers. So I'm just finding the average, in this case, of a specific shape. And there's always a formula that matches with the geometric mean. And it's always, it's going to be some length over x equals x over another length. And that's going to always help me find the geometric mean. And I'm going to utilize this geometric mean in a few moments. So let's now go ahead and talk about what an altitude is. An altitude is a segment that intersects a vertex of a triangle and is perpendicular to its opposite side. So if I looked at this picture, so let's actually write it down first. An altitude is a segment that goes through a vertex and is perpendicular to the opposite side. So if I go ahead and I look at this picture, my altitude in this picture would be CD. I'm coming from a vertex and it's going to be perpendicular to the opposite angle. So if I highlight that, I'll highlight it in green, that would be my altitude. I've briefly discussed this before, however, now it's in our notes. So we have two different theorems in which I can find information based on the altitude or based on by using the geometric mean. So theorem 1 is when I'm finding the altitude. So when finding the altitude. How you find it is its piece of the hypotenuse over the altitude equals the altitude over the other piece of the hypotenuse. So I'm looking at right triangles here. So how I find the altitude is by using the geometric mean. I'm going to take the piece of the hypotenuse over the altitude equals the altitude over the other piece of the hypotenuse. So let's go ahead and let's look at example 1. So I'm going to highlight my altitude. My altitude is this. So what is denoted for my altitude? Well, it's x. So I know it's going to be something over x equals x over something, right? Because the altitude is always in that position. So now it's the piece of the hypotenuse over the altitude. So notice my main 90-degree angle is right there, which means this side is my hypotenuse. So I'm just going to take one piece of it. So notice this altitude cuts my hypotenuse into two pieces. I'm going to take one of the pieces. What's one of the pieces? 3 over the altitude equals the altitude over the other piece. What was the other piece? 12. I call this the snake method. And you can kind of do it. You go piece over the altitude equals the altitude over the other piece. So it kind of looks like a snake if you want to think about it that way. So now I'm going to cross multiply and solve. 3 times 12 is 36. X times x. What's x times x? Well, it's x squared. So now square root, square root. So x equals 6. And I'm done. Let's go over the next one. Find the altitude of triangle ABC. So again, I'm finding the altitude. So my altitude is right here. So I'm going to just do the snake. So I'm going to draw my snake if I need to. Let's draw. Don't erase my numbers. All right. So piece, give me one piece. 4 over the altitude. What's the value of the altitude? X equals the altitude, which is still x, over the other piece of the hypotenuse, which is 9. So I'm now going to cross multiply and solve. X times x is x squared. 4 times 9 is 36. Square root, so x equals 6 again. So go ahead and pause this video, and I want you to try to find x on example 3. When you finish this problem, unpause it, and we'll go over it. So because this is the altitude, I can set up the geometric mean and draw my snake. Piece, what's one piece of the hypotenuse? X over the other piece, which is 8. No, I lied. Let's repeat that. X is my piece of the hypotenuse over the altitude, which is 8, equals the altitude, which is 8, over the other piece, which is 16. So now I'm going to cross multiply and solve. X times 16 is 16x. 8 times 8 is 64. So now I'm going to solve for x by dividing by 16. So x equals 4. The one thing you really have to get out of this is you have to know that the altitude always comes from a vertex. I'm going to sometimes draw a problem like this on your paper, and you're going to think this is the altitude, but it's not because it's not coming from the vertex. So you always want to be very careful with that. Go ahead and flip your paper. Let's now talk about Theorem 2. Theorem 2. Theorem 2 is when finding a leg of the right triangle. So I'm not finding the altitude anymore, but notice in these examples, the altitude is still present, so I know I can find it. So how I find this is its piece of hypotenuse closest to the leg over the leg equals the leg over the whole hypotenuse. Piece of the hypotenuse that's closest to the leg over the leg equals the leg over the whole hypotenuse. There's no real nice way to tell you other than you're going to have to memorize these theorems. I can't tell you any other fun, cutesy way to do it. Sorry. So, if I go ahead and I look at this first example, it says find the leg. So I'm going to highlight my leg. Notice that's a leg. It's the opposite. It's not the hypotenuse. That's one of the other sides. So I want to find the piece of the hypotenuse that's closest to the leg. So I have these numbers here. Which is it? So 12 is the whole hypotenuse, 4 is the piece. This piece over here would be 8 because 4 plus 8 makes 12. So my question is, which piece of the hypotenuse is closest to that blue leg that I highlighted? Well, 4 is closest, so it's going to be 4 over the leg. The value of the leg is x, equals the leg x over the whole hypotenuse. The whole hypotenuse is 12. I'm now going to cross multiply to solve. 4 times 12 is 48. X times x is x squared. I'm now going to square root both of these. Square root of 48, is that a perfect square? No. So, okay, I have to simplify it. So 4 and 12 would work, but that's not the biggest one. 9 doesn't work. How about 16? Does 48 go into 16? Yep, 3 times. 16 and 3. Square root. So I have 4 rad 3 is x. You have to know how to simplify it in simplest radical form. Let's go ahead and let's look at example 2. I'm going to highlight my leg so I can see it. So I want the piece that's closest to the piece of the hypotenuse that's closest to the leg. What piece is closest? 9 over the leg, which is x, equals the leg, which is x, over the whole hypotenuse, which is 25. So now I'm going to go ahead and cross multiply and solve. X times x is x squared. 9 times 25, what's that? 225. I'm now going to square root both of these. The square root of 225 is 15. So x equals 15. Some people like the snake method that I showed you on the altitude. The snake that I would draw here would kind of look like this. So if I draw it again to show you in case you weren't watching. Piece over hypotenuse over leg equals the leg over the whole thing. So some people prefer that way. So let's go ahead and let's look at example 3. Example 3, it says find the missing variables x and y. So which one do you want to find first? Do you want to find x first or do you want to find y first? Well, I clearly can't hear what you're saying, but we're going to go in numerical order. We're going to find x first. So is x the altitude or is x the leg? X is the leg. So when I find the leg, I have to do the piece closest to the leg. So the piece closest is 4. So 4 over the leg equals the leg over the whole hypotenuse. Piece over the leg equals the leg over the whole hypotenuse. What's that whole hypotenuse's length? 9. How I got 9? 4 plus 5 makes 9. Cross multiply. X squared equals 36. So x equals 6. That's x. Let's now talk about y. If I highlight y is the altitude. To find the altitude, it's piece of that hypotenuse over the altitude equals the altitude over the other piece. So what's one piece of the altitude? 5. So if I draw my snake, 5 over the altitude, which is y, equals y over the other piece, which is 4. Now I'm going to cross multiply and solve. Y times y is y squared. 5 times 4 is 20. Square root. Is 20 a perfect square? No. So I have to find the biggest perfect square that goes into it. 4 and 5, square root. So y equals 2 rad 5. So go ahead and pause this video, and I want you to try example 2, and then unpause this video and we'll go over it. Notice example 2 has x, y, and z that you have to solve. So let's see if you can figure it out, and then we'll go over it at the end. So if I go ahead and go in numerical order, I'm going to find x first. Is x in a leg or an altitude? It's the leg. So I have to do piece over the leg equals the leg over the whole thing. So the piece closest is 4 over the leg, which is x, equals the other leg x over the whole thing. 4 and 12 makes 16. Cross multiply, I get 64. So x is 8. So now let's do y. Y. Is y the altitude or is y the hypotenuse? It's the Is y the altitude or is y a leg? It's a leg. So I can't speak today. Let's try that again. Y is not the leg. Y is the altitude. So how I find the altitude is I draw my snake. So it's going to be piece over the altitude equals the altitude over the other piece. Cross multiply, I have y squared equals 48. Square root. I just did 48 on the other side. I know it's 16 and 3. So y is 4 rad 3. And last but not least, if I do z, is z an altitude or is z a leg? Z is the leg. So I'm going to do the piece closest to the leg. So looking at this hypotenuse, what piece is closest to that leg? 12 is. Over the leg equals the leg over the whole hypotenuse. 12 and 4 make 16. I'm now going to cross multiply. Z times z is z squared. 12 times 16 is what? 192. Square root. So if I square root 192, it's not a perfect square. So 192, what goes into that? 64 and 3. So z is 8 rad 3. So go ahead and do number 3. When you finish number 3, you can unpause this video and check your answers. They'll be up on the board. Example 4, however, is the same as example 2, or I believe. It's almost the exact same as example 2, so we don't need to do that one. So go ahead and do example 3 and then unpause this video for you to check your answers. So all of the answers to number 3 are shown. You can pause this video if you all need a little bit longer to check it before it runs out of time. I hope you all have a great day.